Coordination compounds, assignment number 4. In this, we'll discuss about valence bond theory, shapes of coordination compounds. See, the metal d orbitals that are directly facing the ligands in K3COCN6 means, first of all, you have to understand what type of splitting it is. Here you can see CN6 is there, means it is coordination number 6. When coordination number 6 is there, it is octahedral. In octahedral cases, ligands always come along the axis. Along the axis, the orbitals are dx square minus y square and dz square. Directly facing ligands, that is along the axis dx square minus y square and dz square. Done? Next, the correct order of energies of d orbitals of metal ion in a square planar complex. Actually, what happens is in octahedral, it will be like this: Eg orbitals and T2g orbitals. Then in square planar, one comes down, one goes up. Here one goes up, one comes down. The least is dzx, dyz. This is dz square. This is dxy. And this is dx square minus y square. Highest is dx square minus y square, then dxy, then dz square, then xz and yz. Square planar. Here star is mentioned. You can consider that as your answer, right? The difference in the number of unpaired electrons of metal ion in its high spin and low spin octahedral complex is 2. The metal ion is, actually you need to check all the options: nickel plus 2, Mn plus 2, Fe plus 2. I will go with this cobalt plus 2. What is cobalt electronic configuration? Cobalt is 4s2 3d7, right? Cobalt plus 2 means it will be 3d7. Now high spin complex we are discussing, and that to octahedral. Octahedral means 2 orbitals up and 3 orbitals down. Now if you want to go with the d7 configuration, you see 1, 2, 3, 4, 5, 6, 7. 3 unpaired electrons are there. What I have written is high spin. Why high spin? High spin means you give maximum number of unpaired electrons. High spin complex, 3 unpaired electrons are there. I will go with the low spin. 1, 2, 3, 4, 5, 6 and 1 electron is here. So 1 unpaired electron is here. It is here 3 unpaired electrons, here 1 unpaired electron. So difference in the number of unpaired electrons is 2. In this way, you need to check all the options. Correct? Good one. The pair having same magnetic momentum. Same magnetic momentum means there should be same number of unpaired electrons. See here, in both the cases, water is present as the ligand. Water is a weak field ligand. You have to check first 2 options, then these 2 options, every option, till you get the right answer. So it is little time taking, but you need to. Chromium plus 2 configuration is there. Chromium plus 2 means chromium 4s1 3d5. Chromium plus 2 is 3d4 configuration. 6 water molecules are there, so this is octahedral splitting. 1, 2, 3, 4, 5. 1, 2, 3, 4. There are 4 unpaired electrons. Water is a weak field ligand. In this case, you can take, otherwise you go like a sp3d2, d2, sp3 type of hybridizations. Here it will be sp3d2 only, water. In case of iron plus 2 means again d6 configuration. D6 configuration means 1, 2, 3, 4, 5. In this way you can write. Otherwise 1, 2, 3, 4, 5, 6, 4 unpaired electrons are there. Or you can write even like this also. 1, 2, 3, 4, 5, 6. What is the weak field ligand? It is not pairing up this. So 4 unpaired electrons are there. In both the cases, 4 unpaired electrons, so it is your answer. But if won't come na, you need to check second option. You need to check third option. You will get definitely right answer, but it may take some time in these questions. No other way. We'll go with the next one. Look at the next question. Yes. Which of the following facts about the complex hexammine chromium 3 chloride is wrong, is saying. When ammonia is there, D2sp3 hybridization, chromium is in +3 oxidation stage, means 3d3, 4s0, 4p0 in chromium +3. 3d3 means the electronic configuration will be like this: 1, 2, 3, s orbital, p orbitals, and this is the D2sp3 hybridization. All these cross marks are for the 6 ammonias. So D2sp3 is right, octahedral is right, paramagnetic is right because 3 unpaired electrons are there. It's an outer orbital complex is wrong. It is an inner orbital complex. Inside d orbitals are coming in, so this is inner orbital complex. And it gives precipitate with silver nitrate ion, definitely because 3 chlorides are outside, so it is also right statement. So the wrong one is this one. The hybridization of the complex NiCl4 minus 2 is, this is very simple, it's CsP3. It cannot be because 4 ligands are there. And fifth option also it not possible. So fourth option. In these two you need to check. This is a weak field ligand. Weak field ligand generally goes for outer orbital complex. Weak field ligand D8 system. Okay, now D8 means it is sp3. Nickel oxidation state will be +2, that is D8. 4s0, 4p0. D8 means there will be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Chloride is weak field ligand, so it won't pair up the electrons. They will occupy simply outer 1s and 3p orbitals, sp3. Which of the following has a square planar geometry? Platinum coordination 4 always square planar. This is CO. Platinum coordination 4. You can go for 99.99% square planar complexes. Platinum, palladium, nickel, generally. Nickel in 4 coordination number. Generally, when D8 configuration is there, they go for square planar. But in case of nickel, nickel tetracarbonyl, nickel tetracyanide, all these we need to check. Nickel tetracyanide is square planar, nickel tetracarbonyl is tetrahedral. The number of ions formed when cuprammonium sulfate is dissolved in water. Cuprammonium sulfate means Cu NH3 taken 4 outside the square bracket SO4. This is 1 ion, this is 1 ion. Only 2 ions are coming. The shape of the complex species will be square planar if its coordination number is. Square planar is always in case of 4. If it is 5, either square pyramidal or you can say trigonal bipyramidal. 6 is octahedral, 2 is linear. Which of the following is outer orbital complex? Outer orbital complex, when weak ligands are there, it will be outer orbital complex. Weak ligand, outer orbital complex. Strong ligand, inner orbital complex. It is a D2sp3 hybridization. It is sp3d2 hybridization. It is again sp3d2 hybridization. So both 1 and 2. Done. Thank you.